Alright guys, so we're going to take a look at some Desmos problems to kind of help you with the Desmos activity that I sent. If you have a computer or an iPad at home, this activity works best using one of those, but you can also use your cell phone too. So either one works. Okay. So first, we are going to take a look at your slides for the week. So I just put this in here like it's 3 o'clock on the 20th of April, and it took me all day to record this and upload it and put it into this file. It is almost an hour-long video, and it looks like I need to change this because it looked like it was on cap locks. Anyway, if you open this up in YouTube, there are some descriptions. See, to make this big, and then if I hit the escape, oh, there we go. Click on the YouTube button. There are some timestamps in here where you can get to faster stuff. So if I just want to look at part 1, then you open this up. The example in part 1, you can open these 2 links up, and it will skip forward for you in the video, so you don't have to watch the whole thing at one time. You can go piece by piece. Okay, so speaking of, your assignment is broken up into pieces. So the first part, or the first Desmos activity, so you have 3 activities in your slideshow. Let me get back to the slideshow. The first activity is a crossword puzzle. So you just click on here, and there's some vocab words in there. Google is a good resource for vocab words. And you can also watch the video, because I mentioned the vocabulary words a lot in the video as well. So you want to do that. And there's some instructions about how to save it. If you have any questions, please give me a call or send me a text message. Assignment number 2. This is your Desmos activity, and we're going to take a look at this. This part 1 Desmos activity is for parabolas that open up or down only. So if you want to look at the video about this section, you only want to look at the section that talks about parabolas that open up or down. You also want to print out a couple of things or write down a couple of things. One being in the notes. When I did example number 1 and number 2, there was some formulas that I highlighted that you want to write these down, and for each one, okay, from top down. Look through that video and write these down, okay? You also, when you open up Desmos, see if I can find that piece of paper. When you open up the Desmos activity, you'll see a slide that looks like this, and it kind of gives you a list of things you are to graph. And if it asks you to graph and label the parts of the parabola, here are all the different parts of the parabola, and it's color coded, and it talks about what type of lines. I can give you a closer look at that. You want to write this down as well. I just printed this out from part 2 of your assignment, so it's the same for part 1 as well. So let me click on this, and then that way you can see it on my screen. Okay, and so that's what I'm going to show you today, is how to work the different problems, how to change the color and the types of lines of all of these in the Desmos activity. So I have some examples already pulled up for us in our Desmos calculator. Alright, so you're going to definitely need some scratch paper to kind of work some of these things out. Alright, so in the Desmos activity, the first example you're going to see, or problem that you're going to see, is a problem that's given in vertex form. And then the instructions are to identify and label all the parts of the parabola. So going through that list I just showed you, the first thing on the list is to graph it, which is already done for you, okay, and to color it black. To change the color or types of lines or anything in Desmos, you click on this gearbox, and then this will darken out, and you want to click on this circle, the colored circle, and here you can select whatever color you want and whatever type of line you want. So we want a solid line, which is the default, okay, and we want the graph itself to be black. So that's why it's black and it's at default. Okay. The next thing it wants us to do is find the vertex. If you click on the graph, I see that the vertex is the lowest point on the graph, and it kind of highlights it for you. It's -5, -4. So then in the next line, that's what I'm going to type. -5, -4. And then you're going to label it vertex. Okay. And then you're going to want to change this to red if it's not already red. Okay. My default is red. All right. Now, for those of you who are not quite sure what we're looking at, all right. So, if you were paying attention in the notes, okay, the equation is y equals x plus 5 squared minus 4. Okay. The format in vertex form, if I go back to my handy dandy notes, is a different color. Y equals a times x minus h squared plus k. So if it asks me for the vertex is going to be my h comma k, and we have to remember that when we're talking about opens up or opens down, the h will always flip signs. So that's why it is -5, -4. And if you want to write out what A, H, and K is, you write right underneath it. A is 1 because there's nothing in front of the parentheses, so it's automatically 1, not 0. H is opposite what's inside parentheses, so it's -5. And K is exactly what it is. Okay? So that's one of the things. The next thing on the list was the axis of symmetry. The axis of symmetry, you have to write it as an equation. If you look at your notes, axis of symmetry is x equals h. X equals h. Therefore, my axis of symmetry is x equals -5, and that's what I'm going to type in here. X equals, in my Desmos calculator, equals -5. Now, and it puts the line on here for you. Now, my color code says it needs to be a dashed line. It needs to be green. So I'm going to hit this little gearbox. I want to change it to a dashed line, and then change the color to green. Then say done, or click out of it, and then it will change it on your screen. I cannot label I can't label the axis of symmetry, so that's why it's important that you color code it and dash line, do the notation that I sent on there or put on there, so I would know that this represents your axis of symmetry. That helps me grade it. All right, directrix. And the formula sheet, directrix is calculated, or the formula is y equals k minus 1 divided by 4a. Y equals k minus 1 over 4a. So y equals k is -4 minus 1 over 4 times a, which is 1, which is 4, okay? And then you can actually type that in here to get the answer, okay? So -4 minus 1 divided by 4 is -17 over 4, okay? So that's what I want my answer to be. I wonder if I can, oh. I was wondering if I could drag and drop it, and I can, but I don't know where it went, so that didn't work out. So I'm going to close it out, and then I'm going to type y equals, because I need this to show up on my graph. Negative 17 divided by 4. In Desmos, and I will open that up in just a second, there is a calculator on the screen for you that you can actually open up as well. All right. So let me check my timing. Okay, so and then in order to change the color of what it was at first, you hit the gearbox, you click on it, you change it to a dash line, and you type the color you want. So for the directrix, we wanted it to be according to the little handout that I have here, or that first slide that you're going to see in Desmos. You're going to click the orange color, and it needs to be a dash line. Okay, there we go. All right, so next, color coding is very important, especially for equations and lines, because you cannot label it on the graph. So that's kind of how I know what's what. All right, so y-intercepts and x-intercepts, this is not in the notes. This is something you should know. If you can't see the x-intercepts, I think this was like this kind of at first. My video had timed out, so I had to come back. All right, you can pull it down, you can zoom out, you can zoom in, so you can see it. And then if you click on the black graph, it will show you some key important features. So in this one, sorry, I got a little distracted. So if you click on the graph, you will see the key important points. The first point here is the next thing I asked for was the y-intercept. So I want to find where the graph crosses the y-axis, and it crosses it at 0, 21. So I'm going to come down here. I'm actually going to type it down, and I'm going to write it down. The y-intercept is 0, 21. So I'm going to put that here. Then I'm going to label it. And this is the y-intercept. And then you want to color it the way it says color. It says it wants to be purple, and it looks like that was the default color that it went to, so that's gravy. Okay. The next one says x-intercepts. Again, you could click on the black graph, and if you look here, it highlights those points that you need. I need the x-intercept, or where the graph crosses the x-axis. And then I write those down, and I actually can type both of those in here at the same time. 7, 0. Notice how everything is on its individual line. So when you're typing in more than one point like this, separate them by a comma. Make sure you're using parentheses when you need to around those order pairs, and don't put spaces in there. Okay. I'm going to label it. This is x-intercept. Okay. And then it also wants it to change the color to blue. So I'm going to come up here with this gearbox, click on that black circle, and change it to a blue color, and then say done. And then the last thing it wants us to do is find the focus. So the formula for focus is h, k plus 1 divided by 4a. So we got some stuff to fill in. So I'm going to fill it in. -5, -4 plus 1 over 4 times 1. And you could do that math in your calculator first. -4 plus 1 divided 4 times 1 is, make sure you click on the circle to change it to a fraction, especially if your problem has fractions in it. And that's where I come up with -5, -15 over 4. So let's type that in here as an ordered pair. -5, -15 over 4. Okay, and then let's label it. This is the focus. Okay, and then it wants us to change it to an X and to change it black. So if I come up here to the gearbox and click on that, click on the focus, I can change what type of dot I see to an X, and then I can change the color to black, and then say done. Now everything is color coded. I can see everything on the graph and over here in the in this toolbar section. So that's what you have to do in the Desmos activity. So there should be 1, 2, 3, 4, 5, 6 plus the graph, 7 items that I should be able to see on the graph. Some other things they may ask for that's not here is the the minimum and maximum, and the latus rectum. That you cannot graph. All right, so back at the example here. So some other things that the Desmos activity might ask you for that's not that you won't have to graph per se, but you will have to write it down on your, or type it into the Desmos activity, is the latus rectum for one, where you have to find the length of the chord that passes through from one end of the parabola to the other end, passing through the focus. And that formula is the absolute value of 1 divided by A. Our A in this case is 1, so the absolute value of 1 over 1 is just 1. Okay, some other things maybe it asks you what direction the parabola opens up. If you look on the graph, it clearly opens upward. Okay, so you will type in there opens up. Okay, it will ask you if it has a minimum or a maximum. This graph has a minimum, and your minimum or maximum point, I should say min or max, will always be y equals k. Now you have to decide whether it's minimum or maximum. It can't be both. It has to be one or the other. And if the vertex is the lowest possible point on the graph, then that's your minimum. If it's the highest possible point on the graph, then it is your maximum. In other words, a minimum graph is pointed upward, a maximum graph is pointed downward. Okay, so we're going to take a look at another example that you'll have in no, not that one. It's fine. All right, you're given a point and you're given the vertex, and I will already have it typed into the table for you. So we know that the vertex is in the center or in the middle of a parabola. So if I'm given the vertex, that's exactly where I'm going to put it in my table. It takes 3 points to make a quadratic function, not 2. So I have to first find the third point. Find the third point. And all you have to do is, on the opposite side, the y value is going to be the same as the point previously before it. Okay? The x value is what changes. So all I'm doing now is getting the distance between these 2 points. So if this is subtracted, to get from 6 to 4, I have to subtract 2. So that's what I'm going to do to get the next point. To get from 4 to the next one, subtract 2, I get 2. So that third point is 2, 4. And I'm going to type that in my table. All right, so that's just the rules of the vertex. That's why you have the axis of symmetry, because now this dot is 2 units away from the axis of symmetry, if you imagine, if it's there, and then this dot is 2 units away from the axis of symmetry going in the other direction. All right, so now that you have 3 points, okay, in your graph, the directions will be to write it in vertex form. All right, so y equals a times x minus h squared. All right, plus k. Now this one will require you to do a little bit of work, okay, because I have every letter in here except for a. I don't know what a is. Okay, so in order to find a, all you need to do is take one of the points. Let's say I take 6 and 4, 6, 4, and I'm going to plug it in. 4 equals a times 6 minus, I know what the vertex is. It's right here because it was given to me. The middle point is my vertex. All right, so it's 4 plus 3. Okay, all right, so 4 equals a 6 minus 4 is 2 squared plus 3. All right, then I'm going to subtract 3 from both sides. I get 1 equals 4a. divide this side by 1, and I get 1/4 is equal to A. So now I know what A is. So now I can write the equation of my graph. The equation of my graph is y equals 1/4 times x minus 4 plus 3. X minus 4 squared. Alright, so we're actually going to type that into this graph. Y equals, okay, 1 divided by 4, parenthesis, x minus 4 squared plus 3. And look at that. This graph goes through those points that were already on the graph. Alright, so I need to change the color of this. Alright, so I'm changing this to black. And there we go. We can see the green points that were on here from the table already, and we can see the black graph that's on here. Then it's going to ask you, the directions will ask you to label the graph, label the vertex, the axis of symmetry, the focus, the directrix, and the lattice rectum. So I'm not going to do that here, but this is how you do this problem. All right. So once again, you take the table. It will say in the write-up which one of these points is the vertex and which one is just a point that the parabola passes through. So if this is the vertex, then you want to put this vertex in the center. The table will already be set up for you, okay? And it'll have that one point that it passes through in there. So common knowledge that you should know that is, if the vertex is the very center of the parabola, then for every point, as you move it up or down a parabola, it will have the same y value. So this point that it passes through, if it has a y value of 4, then the new point is going to have a y value of 4 because they have to match on either side. All right, so then for the x values, this is where you want to find the difference between the two numbers. So the difference between 6 and 4 is -2 because I'm going from 6 and reducing it to 4, so I have to subtract 2. So that means in this direction I have to do the same thing. So I take 4, subtract 2 from it, and I get 2 as well. Okay, then I have to plug it into the vertex form. Take one of the points, okay, and the vertex, plug it into the formula so you can find what A is, and then write your equation out with the information that you now have. All right, and after you do that, you'll be able to graph it. If you have any problems with this, please let me know. Don't go through this without doing it. All right, so then, okay, so clearly this graph opens upward, and we can see. All right, so let's do one more example. Here we go. I'm given 3 points. All of them are on the parabola, but none of them are the vertex. Okay, none of them are the vertex. So again, you will have a slide that's already set up just like this. If you notice, I've already put the formula in here as well as what A, H, and K is. I've already done that. Okay, so for this example, you might want to write these things down in the format that they are. So y equals A times x minus h squared plus k. Okay, so A is -2. So -2 times x is just x, minus h is a minus -3, so it's going to be plus 3. And then k is 4, so it's plus 4. Oh, and don't forget to put the square, because it's not quadratic without the square. You won't get the U shape. You will get a straight line, and that's not quadratic or parabola for that matter. We can see that this parabola opens down. Now, I want you to practice moving these sliders, okay, and see what these does. When A changes, look how narrow the parabola gets. When it gets bigger, look how wide, and then going positive, it flips over. Matter of fact, you can press play here and it will do this for you over and over again to show you what happens when you change the value of A. Okay, so I'm going to stop it and put this back where it was, is at -2. Okay, the H, look what H does. I'm going to press play. It moves left and right when you change the value of H. If you change H to negative, it moves to the left. If you change H to positive, it moves to the right. Okay, but if you look in your equation and when you have a +3, you might be thinking that this is going to move to the right, but no, a +3 means it's going to move to the left, because remember, H, you have to flip the signs when you're writing it out as H equals, okay? When you're taking that value out. All right, so I'm going to stop this, and then I'm going to change this back to a -3, okay? And then look what happens when you change K. Up, down, up, down. So this one doesn't matter. If K is positive, it moves up. If K is negative, it moves down. It's going back positive, move up. Going back negative, moves down. So the takeaway of this is I pretty much gave you the answer for this last problem, and then it has some questions that follow asking about different parts of the parabola. It might not have you label a graph, but it will have different questions about that particular graph. Okay? So I might have a few minutes to just look at that activity real quick. Get rid of that. All right, so history, part 1. All right, so this is what I see. This is what you will see. You can hit this button right here and it goes into full screen. Okay, here's that list I was telling you about that you may need to write down. Here's a calculator that you can click on for all of your slides to be able to do some math work over in the side. Okay, so you know, here's an example slide of all the parts being labeled just like I did for the example in the video. So you'll have that as a reference, color codes and all. The first problem gives you the equation and it wants you to label all the parts of the parabola, similar to the first example I gave you. Okay. Then based on your answers for this slide, it will feed this graph on this slide. So everything that you label on the beginning will be here on this screen when you click over. So then it has some questions about what is the minimum or the maximum value, and it's got to be written as an equation, y equals k. Okay. All right. What is the length of the lattice rectum? So this is what I was talking about, those questions that you can't really graph, that you require just a little bit of math work to do. You're going to put that here. All right, in this one, this is the second question. It gives you a parabola that has a vertex and it passes through a point, and I've already put the table in here. The first thing you have to do is find a third point. You're going to insert that here, and then you're going to write the equation. So make sure you look at that example number 2 that I wrote down and follow that strategy for writing the equation of a parabola given a vertex and a point. Okay, once you write that equation out, it's going to ask you to graph it and then label all the parts just like you did for the first problem. It'll ask you, so again, this graph, once you label it and everything, will feed into this graph. So then the next question asks if the parabola opens up or down, does it have a minimum, and you're going to select all of that applies. Again, it can't open up and down. It's open up or down in its maximum or minimum. It can't be both, okay? But you're going to select one of these and one of these. And then it has some questions about what their value is. What is the length of the lattice rectum? The last question is the last thing I told you. In this particular one, it gave it to you in standard form and not in and I thought I fixed this. I'm gonna have to go back and change this. I thought I saved this, that I already did this work for you, but I'll go back and fix it. Okay, and then it'll ask you what the equation is to write it here and what format to write it in. Open up or down, maximum, minimum, what is the vertex? How many roots does it have? This is one of your vocabulary words. If you don't know what roots is, I suggest you look it up. And then you're finished. Once you're done, it automatically all you have to do is click the X and it will close out for you and save your data in here. Alright, if you have any questions, you let me know.